Hi everyone, I want to take this chance to discuss what is the logic behind the hypothesis testing. And the best way to approach this question is using this example in here. The example says EMS, the Emergency Medical Service Director, basically wants to perform a hypothesis testing and see whether the average service time essentially is 12 minutes or less. And so based on that assumption, we made a law hypothesis, that is the average responsible time less or equal than 12 minutes. And alternatively, then of course the average time is greater than 12 minutes. And so that's basically the law and an alternative hypothesis. Now, in order for us to uh, investigate that, then we have to obtain a sample, and the sample size essentially is 40 observations. And based on the sample information, then we try to infer what's going on in the population mean. So that essentially is the states. And I want to jump, after this basic understanding of the situation, then I want to jump to this graph in here because I want to discuss the logic behind the law hypothesis testing, the hypothesis testing, and under what circumstances we say that we reject the law hypothesis. So once you get a sample, if our original assumption is correct, that is, the average response time is less or equal than 12 minutes, then what we can say, if it's based on the sample, once you convert the sample mean into z-value, you would like to say 95% chances that the z-value should fall into this range on the left-hand side of 1.645. The reason, think of this, what does this mean? Essentially, it's the follows. I want to use another example. If you believe, let's use the class as example. If you believe all the classmates are millionaires, let's say millionaires, and so now, okay, the law hypothesis essentially says the whole class, on average, essentially they are millionaires. And so you're going to go ahead, collect some sample to test the law hypothesis. Now, if you find if you randomly select one sample, before you actually expect any answer, you would like to say 95% chances that you expect the response at least is close to $1 million. Okay, in other words, 95% chances that the response should be in this area. Now, by chance, okay, you randomly select one of the classmates, and this classmate basically says no, his income or her income is far below $1 million, say $10,000 per year. That chance, if the law hypothesis is correct, then that kind of chance should be very low. All right, maybe you limit yourself to 5%. And so now the question is, okay, the lower frequency event occurred, all right, then you start to think about, okay, maybe my original law hypothesis is not necessarily correct, because if it's correct, then I expect 95% chance that I should expect an answer close to 1 million. Instead, you get an answer in say in this case on the right tail, on the right hand side of 1.645. So you want to say, okay, surprise, and instead you don't like surprise. Any surprise, you then have sufficient evidence to reject law hypothesis. In other words, you reject that the average classmates are millionaires. And so this similar logic applies in this situation. You expect once you get a sample, you convert in the z-value, 95% chances that you should expect that the z-value should be below 1.645, because the law hypothesizes that the average response time is less or equal than 12 minutes. So 95% chance that you should expect that z-value should fall into this range. Now, based on this sample you obtained, the sample says the average is 13.25 minutes, and the standard deviation of this population is 3.2. So you calculate a z-value associated with the sample says actually 2.47. So it actually falls into this range, okay, on the right hand side of 1.645. Surprise, because the chance you're going to see a value in this range is only 5%. Yet you observe that. So now you can come back to be suspect about your original assumption. That is, the original assumption mean response time less or equal than 12 minutes. Maybe that's not correct. So you're going to reject, based on that logic, you're going to reject the law hypothesis and maybe accept the alternative hypothesis. All right. Now, in this case, we also says instead of rely on z-value, if you only rely on z-value, which is z equals 2.47, and compare this 2.47 against the critical value, which is 1.645, and then you say that because 2.47 is greater than 1.645, it falls out of the accepted area. It's actually falling into this rejection area. Then you reject the law hypothesis. If that's the case, we say you're using the critical value approach. And critical value approach basically doesn't say specific about what kind of error, what's the chances of error you make. And so sometimes people want to get in further and talk about the p-value approach. In other words, you want to say at what kind of chances that you can feel comfortable to reject the law hypothesis. All right, I want to minimize, okay, the amount of errors. In other words, if you minimize the errors you make by rejecting a true law hypothesis, then you actually increase the confidence level. That's the opposite. The confidence level essentially is the opposite of this value. Okay, it's 1 subtract 0.0068. So in this case, you find out, okay, for z-value equals to 2.47, the chance that the probability of anything above this 2.47 essentially is only 0.0068. And so you can say, okay, you can feel comfortable to reject the law hypothesis, and with a significance level only equals to 0.0068, which is more accurate than 0.005 in this situation. In other words, why I say more accurate is because it provides exact amount of error. In other words, type 1 error you could potentially make. You only make about 0.0068, in other words 0.68% of type 1 error if you reject the law hypothesis, which is pretty comfortable because, again, we want to limit the type 1 error not to at least not exceeding 10%. Okay, and so that's the logic behind this law, the hypothesis testing. In other words, you don't lack surprise. Anything, if it's a surprise falling beyond the comfortable zone, then you can reject the law hypothesis. Thank you for watching.